Welcome to MarkScheme. Straight lines. Everything you need made visual. Look at these two roads. One climbs gently to the right, the other drops steeply, and they cross at a perfect right angle. Here's a question that sounds like geometry, but is really algebra. If you know how steep one road is, what does that force the other one's steepness to be? By the end of this video, that link will be a single, clean rule. And so will everything else about straight lines. Their gradient, the three ways to write their equation, where they cross the axis, and when two of them are parallel or perpendicular. One topic, no gaps. Here's exactly what we cover. Straight from the syllabus. Analysis and approaches. Standard level 2.1. The gradient of a line and its intercepts with the axis. The three standard forms of a line's equation, including the point gradient form, and the parallel and perpendicular conditions. Every one of these is on SL 2.1, and none of it is HL only. So there's nothing to skip. Start with the single most important number for a line. Its gradient, written m. It measures steepness. Take any 2 points on the line and walk from one to the other. The horizontal step is the run. The vertical step is the rise. Gradient is simply rise divided by run. How much you climb for each step across. As a formula, that's y2 minus y1 over x2 minus x1. The change in y over the change in x. Here we rise 3 and run 4. So the gradient is 3/4. Keep the order consistent. Whichever point you call first for the y's, use the same one for the x's. The sign of the gradient tells you the direction. Positive means the line goes uphill as you read left to right. Negative means downhill. Zero gradient is a flat, horizontal line. No rise at all. And the vertical line has an undefined gradient, because the run is 0 and you can't divide by 0. Hold on to that last one. It's an exam trap we'll come back to. Every straight line is one object, but the exam writes it 3 different ways, and you must be fluent in all 3. First, slope-intercept form. Y equals mx plus c. This is the friendliest, because you can read the gradient m and the y-intercept c straight off it. Second, point gradient form. Y minus y, 1 equals m times x minus x1. This is the one you build from scratch. It needs just a gradient and any single point the line passes through. Third, the general form. Ix plus by plus d equals 0. Everything on one side, usually with neat whole number coefficients. These aren't different lines. They're the same line in different clothing, and you convert by rearranging. Start in point gradient form. Minus 3 equals 2 times x minus 1. Expand the bracket. Minus 3 equals 2, x minus 2. Add 3 to both sides, and you land in slope-intercept form. Y equals 2x plus 1. And to reach the general form, just move everything to one side. 2x minus y plus 1 equals 0. Same line, 3 costumes. The golden habit, which will lean on all video, is to rearrange into y equals mx plus c whenever you need the gradient, because then m is just sitting there in front of the x. 2 special points sit on almost every exam line, where it crosses each axis. To find the y-intercept, set x to 0, and in y equals mx plus c, that leaves y equals c. So the y-intercept is just c. For y equals 2x plus 1, that's the point 0, 1. For the x-intercept, do the mirror image. Set y to 0 and solve for x. 0 equals 2. X plus 1 gives x equals minus a half. So the line cuts the x-axis at minus a half. 0. Set x to 0 for the y-intercept. Set y to 0 for the x-intercept. That swap is all there is to it. Here's the heart of the topic, and it's worth slowing down for. On screen is the line y equals mx plus c. And I'm going to move m and c and let you watch what each one does. The gold dot marks the y-intercept. The point 0c. First, change only the gradient m. As m grows, the line tips steeper. Make it negative and it tilts the other way, sloping downhill. But notice what stays nailed in place? The y-intercept. Every one of these lines still passes through 0, 1. Changing m pivots the line about that fixed point. Now hold the gradient still and change only c. The whole line slides straight up and down, and the y-intercept rides with it, because c is exactly the height where the line crosses the y-axis. So m controls the tilt, and c controls the height. Two knobs, and between them, they build every non-vertical line there is. And this hands us the parallel rule for free. Here's a second line, in purple, with a different intercept, but the same gradient as the blue one. Watch. As I turn the gradient, both lines tilt together and stay exactly the same distance apart. They never meet. Two lines are parallel precisely when their gradients are equal. m1 equals m2. Now, the perpendicular rule. The answer to our opening question about the two roads. Here are two lines through the origin that are always at right angles. The blue one and the gold one, with a little green square, marking the perfect corner between them. Watch the two gradients as I rotate the pair. When the blue line is gently sloped, the gold one is steep and negative. When blue steepens, gold flattens the other way. They're locked together, and the lock is this. Look at the product of the two gradients at the bottom. No matter how I turn them, m1 times m2 stays pinned at exactly -1. Rearranged, that rule is a recipe. If m1 times m2 is -1, then m2 is -1 over m1, the negative reciprocal. In plain words, flip the fraction upside down and flip the sign. If a line has gradient 2, the perpendicular gradient is -1/2. If it's -3/4, flip and change sign to get +4/3. Flip it and change the sign. That's the whole move. Before the worked examples, 3 edge cases that catch people out. A horizontal line has 0 gradient, and its equation is just y equals a constant. Here, y equals 2, because the height never changes. There's no x in it at all. A vertical line is the awkward one. Its run is 0, so rise over run divides by 0. The gradient is undefined, and you simply cannot write it as y equals mx plus c. Instead, its equation is x equals a constant. Here, x equals -1.5. If an exam line is vertical, don't fight the formula. Just write x equals something. And one fact, worth stating plainly. Parallel lines have equal gradients, so they never meet. There's no point of intersection to find. If you ever solve two line equations, and the x's cancel to give something impossible, that's the algebra telling you the lines are parallel. Time to use all of this on a ladder of 4 examples, easy to hard. All my own numbers in AB style. Part 1. The simplest. Find the equation of the line with gradient 2 that passes through the point 1, 5. Reach for point gradient form, because that's exactly what we're given. A gradient and a point. Substitute. Minus 5 equals 2 times e to x minus 1. Expand the bracket to get y minus 5 equals 2, x minus 2. Then add 5 to both sides. The line is y equals 2x plus 3. Notice the gradient is still 2, exactly as required. Part 2. Find the line through 2 points, 1, 3 and 4, 9. With 2 points and no gradient given, there's a clear order. Gradient first, equation second. Gradient is change in y over change in x. 9 minus 3 over 4 minus 1, which is 6 over 3. That's 2. Now feed that gradient and either point into point gradient form. Using 1, 3. Y minus 3 equals 2 times x minus 1, which tidies to y equals 2x plus 1. Always sanity check with the other point. Put x equals 4 in. 2 times 4 plus y plus 1 is 9. And that's exactly the weighted we were given. So the line really does pass through both. That check costs seconds and catches slips. This line, y equals 2x plus 1, comes back in the next two parts. Part 3 brings in the perpendicular rule. Find the line perpendicular to y equals 2x plus 1 that goes through the point 4, 3. Step 1 is always to read off the gradient of the line you're given. It's already in y equals m, x plus c form, so its gradient is 2. Now flip it and change the sign. The perpendicular gradient is minus 1 over 2, which is minus a half. Then it's just point gradient form, with that new gradient through 4, 3. Y minus 3 equals minus a half times dirt x minus 4. Expand, minus a half for x plus 2. And add 3 to both sides. The perpendicular line is y equals minus a half x plus 5. Quick check on the gradients. 2 times minus a half is minus 1. The perpendicular condition holds, so we've got it right. Part 4. The harder one. Where do two lines cross? At the crossing point, both equations are true at once, so the y values are equal. Set the right-hand sides equal to each other. 2x plus 1 equals minus x plus 7. Solve for x. Gather the x's. 3x equals 6, so x equals 2. Then put x equals 2 back into either line. The first is easiest. To get equals 2 times 2 plus 1, which is 5. So the lines meet at the point 2, 5. There it is on the graph, exactly where the blue and gold lines cross. Answer: 2, 5. Solving two lines simultaneously is the same as finding where their graphs intersect, which is why your calculator's intersect tool gives the same point. Now, the exam craft that separates the fast candidates from the slow. The single most useful habit. Whenever you need a gradient, rearrange the equation into y equals mx plus c first. And then m is simply the number sitting in front of x. No guessing. And commit the perpendicular flip to memory. Swap the fraction, top to bottom, and change its sign. 4 rules to bank. 1. Always rearrange to y equals mx plus c to read the gradient off. 2. Perpendicular means flip the fraction and change the sign. A reciprocal, not just a minus. 3. For the crossing point of two lines, your calculator's intersect tool is fast and checks you're working. And 4. The midpoint is just the average of the coordinates. and distance is Pythagoras on the rise and run. Both turn up in perpendicular bisector questions. Finally, the 4 traps. 1. Flipping the gradient upside down. It is rise over run, change in y on top, change in x on the bottom, never the other way around. 2. Thinking perpendicular just means a minus sign. The perpendicular of gradient 2 is minus a half, not minus 2. You must take the reciprocal as well. 3. Reading the gradient off before rearranging. From 3x minus y equals 6, you must isolate y first. Y equals 3x minus 6, and only then is the gradient 3. And 4. Trying to force a vertical line into y equals mx plus c. It won't fit. Its gradient is undefined. So write x equals a constant instead. Avoid these 4. And straight lines are guaranteed marks. And that's SL 2.1. Fully covered. The gradient as rise over run, the 3 forms of a line, and how to switch between them, the x and y intercepts, and the 2 rules that decide everything. Parallel means equal gradients, and perpendicular means gradients that multiply to -1. Next in the course, we step up a level and ask, what actually is a function? For more, that's MarkScheme.app. See you there.